The biggest problem facing the design companies today is the growing chip design sizes. So we are today, as people go to 14 nanometer, 20 nanometer designs, they are looking at 10 million cells, 50 million cell designs. Many designs have 70, 80 blocks. So the design sizes are exploding. And the practical outcome of this is that because tools today cannot handle large designs, people have to break up the designs. And once you break it up, each block needs one designer. So that results in a large design team size. When you are trying to bring all these blocks together, again, the technical problem becomes very complex in terms of closing timing with all these different moving pieces. So this is a big problem. The current tools today, they have tried using multi-threading to speed up the throughput, but if you look at the way tools are structured today, multi-threading only goes up to a certain point. Because the Amdahl's law, you see that you do not get scaling when you start going to too many CPUs. And that bottleneck causes people to break up the design. People typically want to iterate over the entire design in a week. So using that as a rule of thumb, usually people break up the design into 2 million cell pieces. That has been slowly growing up, but it's not keeping pace with the way design sizes are growing. Magma is taking a very innovative approach to this problem. All the existing solutions today rely on multi-threading to go as fast as possible to shrink the schedule times. What we are doing is we are leveraging our Vortex technology, but distributing it across a network of machines. And what that enables us to do is two things. We are able to do much bigger block sizes than anyone else can do today because we are not limited by how much you can handle on one machine. And we are looking at doing 8 million, 10 million cells flat. So if you take a big design with 30, 40, 50 million cells, instead of breaking it up into 30, 40 pieces, we can now do that into 3 or 4 pieces. So that's a huge reduction in the number of blocks, the complexity of design closure, and the team size you need for that. We also get much better throughput because now we are working on multiple machines. So this is speed up that you get in addition to multi-threading. And as a result of that, we expect to hit about 2 million cells a day. And what that does is that apart from making it possible to go 10 million cells flat, even if you take designs that are in the middle range, 3, 4, 5 million cells, you can turn them around much faster in a couple of days instead of 8, 10 days. And so across the board for medium to large size designs, we get both big schedule improvement, turnaround time improvement, as well as the ability to do big designs with much smaller team size. So you put it all together and you get cost benefit, both in terms of time to market as well as the investment it takes to get a chip out of the door.